The ocean is beautiful. Even a beautiful person can be a monster when they reach their limits. Hello netizens, today I'm going to talk about the awesome experiment undertaken by MIT engineers. In April 2022, MIT engineers found a way to predict how waves break using wave tank test and machine learning data. Wave breaking determines the sea's attributes and determines the ocean atmosphere interactions, ocean pollution and rogue waves. Wave breaking is a method to determine the energy imputed by ocean waves with wind and flow across the spectrum by non-linearity. But because waves break chaotically, direct numerical simulation are not a good way to solve this problem. To solve this problem, the researchers have developed a hybrid machine learning framework that uses a physics-based nonlinear evolution model for deep water waves that don't break and a recurrent neural network to predict how breaking waves will change in the future. MIT engineers have developed a new model to determine how waves break up. Using data from wave tank test and machine learning, the researchers changed previous equations to predict how waves behave. Engineers usually use these equations to help them build offshore platforms and other strong structures. But until recently, equations couldn't capture the complexity of how waves break. Researchers found that the updated model could predict how and when waves could break more accurately. For example, the model better predicted how steep a wave would be before it broke and how much energy and how often it would break than the usual wave equations. Also, if we know exactly how these waves interact, we can make better structure out at sea. It can also show us how the ocean and air work together. If scientists know more about how waves break, they can figure out how much carbon dioxide and other gases from the air can sea absorb. Scientists usually employ one of the two methods. In the first method, they try to simulate the wave based on individual molecules of water and air. And another, they try to characterize the waves with actual measurements. The first method could cost more than it is hard to simulate in a small area. And the second method is time consuming to yield significant results. The MIT engineers employed some parts from both methods to yield more accurate machine learning models. They trained the model with a set of equations considered standard descriptive for wave behavior and aimed to train the model with data of breaking waves from the actual experiments. Researchers ran tests in a 40-meter long tank to find out how waves break. The team used a paddle at one end of the wave tank to start at each wave. First, the team placed the paddle to create a wave breaking in the middle of the tank. Then, as the waves moved down the tank, gauges, an instrumental tool which gives the visual display of the water level, were used to measure how high the water rose in the tank. For safe harbor, about 250 experiments were conducted. These tests were used to train a machine learning neural network. The method compares experimental waves to model waves. The algorithm updates the model if there are any discrepancies. After training the system using experimental data, the researchers measured two distinct texts in wave tanks. According to these tests, the upgraded model predicted more accurately than the basic model. It was better at forecasting a wave steepness. The revised model accounted for the wave downshift. The new model can tell you how the frequency of waves changes before and after they break. It could help the people along the coastline get ready for storms. Also, the team's updated wave model is in the form for an open source code. You can also use simulations to test offshore platforms and structure near the coast with the code. If you like this video, hit the like button, share it with your friends and subscribe to the LearnWay channel. And don't forget to press the bell icon.